talk about how to use Microsoft Solver to solve a linear programming problem. We start with the statement of the problem itself, a paragraph. From that paragraph, we translate the data into a table. It helps us organize all the numbers. And then we use that table to help us formulate the problem in terms of our constraints and our objective function, which we're trying to either maximize or minimize. So with this farmer problem, linear programming problem in mind, let's see if we can use Excel Solver to find a solution. Taking all the information from the previous spreadsheet, we list the objective function, the changing variable cells. In this problem we have three variables, X, Y, and Z, which represent the number of acres of crops A, B, and C. And we also copy the constraints that we had on the other sheet. In Excel Solver, we're going to need to input a function for the objective function and each of the constraints. For the objective function, let's say we put the function itself in this cell. I'm going to color that just as a reminder to myself where it is in the future. Each of the changing variable cells, X, Y, and Z, we also need to reserve a cell for those. I'm going to color those also. It's not necessary, but it's just a reminder to me where those cells are. We will need to put formulas in for these three constraints, and I'm going to paint those cells with a color also, just to remind myself where those formulas are. All right, let's go back to the objective function. And we need to put in the function, start with an equal sign always, and the profit would equal 100x plus 300y plus 200z. So I'm going to multiply 100 times x, but not the letter x, the changing variable cell x, which has the location B7. So I could type in B7 or just click on that location. The next part of the objective function is plus 300 times y, plus 300 times y, but again, it's not the letter y, it's the cell location of this changing variable cell y, B8. And then the last part of the profit function is 200z, plus 200 times the z cell. After you enter that formula for the objective function, hit enter, and you should see a 0 in that cell. We also need to put in the formulas for the left-hand side of each of these constraints. Always start with an equal sign. Now the left side of this constraint is 40 times x plus 20 times y plus 30 times z. So we start off 40 times x, but not the letter x, it's the changing variable cell location for x, which is B7, plus 20y plus 30z. When you have that formula entered, hit enter. Should have a 0 there. And now we'll do the same thing for the other constraints. We want x plus 2y plus z in our formula. Equal sign, x plus 2 times y plus z. Enter. And the next constraint, x plus y plus z. X plus y plus z. The non-negative constraints, actually we do not need to put in formulas for those. Excel Solver takes care of that automatically. So we're done, we're ready to use Excel Solver. If you click on the Data tab at the top, we should have this Add-in Solver. Click on that. Notice the first thing we need to do is to give the location of our objective function. All you need to do is click on the cell where we had that formula. That's why I painted that cell, so I would remember where that location is. We're trying to maximize the profit, so make sure you bubble in maximum. If you wanted to minimize the objective function, you could bubble in min. Then next we need to give the location of the changing variable cells. Those are the cells that I had painted. The easiest way is just click and drag, and you have the locations. Next we're going to put in our constraints one at a time. Click Add. The cell reference is the left side of that inequality. It's the formula that we put in. So all you have to do is click on that cell location. The inequality symbol is correct, but you could change it to greater than or equal to if you needed to in a different problem in that drop-down menu. And then the right side of our inequality was 3,200. So that takes care of the first constraint. Now we can add the next one. Just click on the Add button. The cell reference is the left side of that inequality, which is contained in our formula, less than or equal to 160. Then we add the next constraint. Cell reference is the formula for x plus y plus z, less than or equal to 100. And those are the only three constraints that we need to be concerned with. So we click OK. So notice down below here, there's a checkbox, make unconstrained variables non-negative. So x greater than or equal to 0, y greater than or equal to 0, z greater than or equal to 0 are presumed to be non-negative when you check this box. That's why we don't need to put formulas in for those constraints. Finally, select the solving method, choose the simplex LP linear programming method, and we're ready to go. Click Solve. It says solver found a solution. Let's take a look. In the solution provided by Excel Solver, it says the maximum profit that we could have in this situation is $26,000. And when does this happen? When x equals 0, y equals 60, and z equals 40. In other words, we have 0 acres of crop A to be used, 60 acres of crop B, and 40 acres of crop C. That's the solution to our linear programming problem using Solver.